Hello. In this video I'd like to do a couple of things. One, introduce the idea of this section of the course, which is bivariate associations, bivariate measures of association. Also a way of interpreting this is explanations of why y varies by using X perhaps as an explanation. I'll talk a little more about that. Talk about the background of what this is, and then spend some time specifically with crosstabulations, where we take two categorical variables and put them in a table and examine their relationship from a statistical standpoint, whether that relationship is statistically significant or not. So we'll begin with chapter 12. It's kind of the concept philosophical piece, if you will, for introducing bivariate relationships. Bivariate measures of association. Now here we say association. Like take for an example, the common one that's used for illustrations. Income varies. Why does income vary? That's the y variable. Why does it vary? And we might hypothesize that it varies because of education. You're probably getting your college education with the idea that as your education increases, so also will your income. And so what we look at here, we measure what is the whether there's a relationship, what's the strength of that relationship, and what's the direction of that relationship, which we'll talk about on this side of the table here in a minute, the whiteboard. But the word association is important here because it's not about cause. Just because your education goes up to college level doesn't necessarily mean that you'll get more income. What you do with your education is what determines your income. Oh, sure, you could probably apply for a job that requires a minimum standard of a college education and make more money just by virtue of that over someone who has just a high school education. But for the most part, the value you get from your education is your human capital. How do you capitalize on that in terms from your own heart and mind and going out for work, that you can turn that college education into something not only meaningful, but financially substantial for you. So we use association rather than cause, because it's very likely, let's say, if it were cause, then anyone who had 16 years of education would basically have the same amount of income, and that ain't the way it works. So we just talk about association of two variables, how they relate to one another, how education relates to income. And then the other part of what we want to talk about here, we're talking about, is that why is our question that we're trying to answer. Why does income vary? In fact, you might, just for fun, you could put a little WH up there and say, why does income vary? We say it varies because of education. Maybe that's a hypothesis that we're saying. Or it might vary by gender. You know, used to be in the old days, men would get more money for the same amount of education experience than women. Fortunately, that's not happening so much anymore. But anyway, what does this variation Y depend on? What does it depend on? And we're saying that it depends on the independent variable on the right, that it depends on the variation in X. Now we say independent because we're only doing bivariate relationships here, but we might have 1 plus x2 plus x3, let's say. Those are x's, not y's. Then we might want to say, what is the relationship between, say, education and income, independently of gender and income, independently of region of the country and income. So we think of it independently because we put a number of variables on the right-hand side to allow us to look at the relationship of each variable with the outcome variable independently of the other independent variables. So that's why we get this thing independent. When we get, in a couple of weeks, when we get to predictive statistics and regression, we'll call this a predictive variable. Dependent variable, we'll actually call this a response variable, is responding to predictive. But that's another story later. Okay, the other thing to think about here, let's go back to level of measurement. We're going to go through three kinds of bivariate measures of association over the next couple of weeks. The one we're doing this week is crosstabulations, where you have two categorical variables, say sex by, or say approval of gun control by sex. Approval would be yes or no, sex is male or female. Both those are categorical. So we could put them in a cross-tabulated system. We'll talk more about Chapter 11 here in a minute. I'll erase this and put some stuff up on having to do with Chapter 11. So if your variables are categorical, you'd use crosstabs. If your dependent variable is continuous and your predictor variable, independent variable, is categorical, you'd use analysis of variance. That's Chapter 10, and we'll talk about that next week. For example, using education again, we might say that continuous variable is education and the categorical variable is gender. And or sex. What analysis of variance will do is it'll take the average income for males and the average income for females and compare those averages to see if they're statistically significantly different. So that's how analysis of variance works. A continuous outcome variable, y variable, and a categorical independent variable. Now correlation is where you've got a continuous variable equaling a continuous variable, like y equals x. Here education or income equals education. Both those are continuous. So this is an interesting little matrix. Keep around. You won't find it out there too much, but it's a nice little reference. If I've got two categorical, I'm doing crosstabs. If I've got a categorical independent variable and a continuous outcome variable, I'm going to use ANOVA. If I've got two continuous variables, I'm going to use correlation. So it's just a handy little reference. Again, you won't find it out there too much, but just something I created some years ago for my own reference and orientation, and maybe it'll be of some help to you as well. All right. Further on in Chapter 12, we're talking about, you'll see as you move into the first couple of pages of Chapter 12, what we just talked about a few minutes ago is the material of that first 2 or 3 pages. So what I want to take you to now is more of the heart of Chapter 12, and that are the characteristics of association. How do we know there's an association, whether there is one? This is in section 12.3. What is the strength of that association, and what is the direction of that association? So when we're talking about whether, one of the things we want to do, and you'll see this here in a minute, I'll pull the book out here. You want to characterize the table with percentages, so we can look at percentages difference from one column to the other, and I'll give an illustration of that here in a minute. But the issue here that will lead us into Chapter 11 is the null hypothesis, whether those two variables are dependent. In other words, one is influenced by the other, y is influenced by x, or they're independent, the y is not influenced by x. So if we can see that there is some dependence in there as we go through Chapter 12, then we know there's a relationship. And then we can measure the strength of the relationship. And this brings us the idea about why you want to do column percentages, and we'll walk our way through this in a minute. You do the column percentages and you can figure out there should be a, I'll just leave it here. The maximum difference, we're going to subtract percentages from another percentage, and we'll do a demonstration here in a second. That will give us, using the scales in 12.5, whether that difference that we see is, or that relationship we see is a strong one or a weak one or a trivial one. And then the direction. Now we know ordinal, remember ordinal, has a implied scale. So if something, y can respond to x in a positive way, or it can respond in a negative way, where y goes up and x goes down, or y goes down as x goes up. And we'll look at those here in a second. Nominal is, since those are categorical variables without a scale, then we look for the pattern of relationship we see in the table. For ordinal, we can say that they're positive or negative related, and you'll see that in a minute. But for nominal, we have to look at the pattern because there's no scale implied there. So this piece right here is really the heart of Chapter 12. There's some introductory piece of Chapter 12, but get your mind inside Chapter 12 and get a feel for what Chapter 12 is all about. And let's take a look, before I erase the board, at some illustrations in Chapter 12. I'm opening up the text here, and I want to point out Table 12.1 on page 296. Here we've got two variables. The dependent variable is job productivity, low, moderate, and high. The predictor variable is job satisfaction, low, moderate, or high. My guess is the hypothesis here, if we were to read the text, is that as job satisfaction goes up, so does productivity. In other words, they're positively related. As one goes up, the other goes up. It probably is not the case that as job satisfaction, you feel better at your job, your productivity is going to go down, which in that case would be as satisfaction goes up, productivity goes down. That would be a negative relationship. But that's probably not what we're talking about here. So when we look at that table 12.1 and say we look at the high row in productivity, one thing we want to say now, and introduce it now because we'll talk about it when we get to chapter 11, is that in these kinds of tables, this is a cross-tabulated table where two variables are laid across a table, crosstabs, affectionately named. The y variable is always in the row, and the independent variable is always in the columns. So there you see job satisfaction as the x variable in our equation, and productivity is the y variable in our equation. But if we look at high under productivity, and you follow across with your finger from low job satisfaction to job satisfaction moderate to high job satisfaction, we see increasing numbers, which suggests to us indeed that it is a positive relationship, that productivity goes up as job satisfaction goes up. Now, it's easy to see in these numbers because the frequencies here are small numbers, 20, 30, whatever. But if it was 453 or 2,927, it would not be so easy to see from cell to cell. So that speaks to the idea of why we want to put percentages in these things. And if you come down and you look at table 12.2 on page 297, you'll see that what was in table 12.1 is now recast into percentages. Now you're probably asking, how do I do percentages? And you know how to do percentages, but the way you would do it is like, say, for example, in 12.1, where you see 30 people said they have low job satisfaction and low productivity. So you have 30 in the upper left-hand corner of the table of 12.1. That 30 is divided by the column total, 60. And if you look at 12.2, indeed, that's 50%. And if you were to divide each of those values in those columns by their column total, you would get the percentages you get in 12.2. So then when you look at the percentages, then it becomes more interpretable. You look at this and you go, whoa, look at that. In the high category, all the way over, almost 52% of the people who report high job satisfaction also have high productivity. And then when you look at the low relationship, 50% of the people who report low job satisfaction report low productivity. So there you see there is indeed a relationship, and we can interpret it in the column percentages. In other words, there is a dependency here. The job performance or productivity depends on job satisfaction, at least to some extent. These variables are not independent. They are dependent. If they were independent, these percentages would all be about the same and they'd be trivially different and we couldn't really interpret them. But they're very clearly pronounced differences. So we can say that this is a dependent relationship. Y does indeed depend on X. Productivity does indeed, to some extent, depend on satisfaction. Now we know that there's a percent, there is something there. What's the strength? So if you come over here a little ways, where it says how strong is the association on page 298, keep going over to 301 and you'll come to something called maximum difference. And the way we would find that out is you would go back here to, let me get this out, you would go back to that table 12.1, and where it says, let's just round it up to 52. Let's say 52 minus, on the low end of high, is about 17. I'm in that low column, the low row of table 12.2, subtracting the low high from the high high, if I can put it that way, that intersection, and you get about 35%. So then if you look at that table at the bottom, 12.5, at the bottom of 301, and look at that scale there, you can see that more than 30 percentage points, which that is, means it's a strong relationship. So then we can say, doing the maximum difference between those two values, subtracting the low from the high, that there's a strong relationship between productivity and job satisfaction. Está muy cool, no? So then, the next question that we have in page 302 is, what's a direction? Well, this is an ordinal variable, is it not? If you look at this, we got three orders, low, moderate, and high, and another set of orders, low, moderate, and high for production. So this is an ordinal. There's a scale implied there. Even though there's no values, we know that low is lower than high and high is lower than low. So we get the sense of it. So then we can say these are ordinal variables. They have an order. And then we can speak to whether it's a positive or negative relationship. If we see, for example, that as job satisfaction increased, job production went down, we'd say that's a negative relationship because they go in different directions. But if we see, as we do, that as job satisfaction goes up, so also does job production, then productivity, then that's a positive relationship. So there we know that in this illustration, it's a positive relationship. Now, let's take a look at an example of nominal, and I draw your attention to on page 304. It didn't have a page, but it's called Reading Statistics 10, the Importance of Percentages. If you see 303 and then you flip over, it doesn't have a page, but it says it'll be 304. Table 1 is support for affirmative action by racial groups. That first table, you'll see racial group is white and black, and support is yes and no. Both of those are nominal variables. There's no order between them, nominal. So we don't have an opportunity to do a positive or negative relationship here. We have to look for the pattern in the percentage distribution and do our interpretation. So when we look at this, you could say, you look at this and you say, well, the pattern here suggests to me that neither group has a majority that is in favor of affirmative action. Rather, both groups, at least the majority in both groups, does not favor affirmative action, but the white group favors it even less than does the African American group. And you can see one is 88.5 no, and the other one is 57 no. So in ordinal, you got fairly straightforward. It's a positive relationship, etc. Patterns for nominal, you got to kind of fiddle with the text a little bit to get something meaningful. Where here you would say that both African American and non-Hispanic whites, for the most part, their majorities, at least the majorities, do not approve of affirmative action, but the non-Hispanic whites more so than do African Americans. So that's the way you describe that pattern. Okay, now let's back up to chapter 11 and look at a couple of things. So I'm going to erase what we got up here real quick. Here we're going to look at the formal side of cross-tabulations. And as you scan through this chapter, and as we do together, you'll see that the calculations are pretty, well, not so much complex, because you could do them. You've become quite accomplished at being statisticians, but it's a lot of work. It would take you probably the better part of 2 or 3 hours just to do one, and if I said you got to do 6, then what would be the point of that? When SPSS, a statistical package for social sciences, will do the calculations for you. You just sit there and decide, I've got 2 categorical variables, so I'm going to do a cross-tabulation in SPSS, and then it'll run it for you. And what you're going to see here in a minute when we look at the homework or the demonstrations is the output and how we're going to interpret it. But before we get there, let's look at chi-square chapter 11, hypothesis testing. And yes, that's exactly what it is, hypothesis testing. Just like we did before, you're going to have a chi-square observed that will come out of your calculations or the SPSS calculations, and you will use degrees of freedom like you did for the t-distribution in the last 2 chapters, 8 and 9. You'll do the degrees of freedom and go to Appendix C in the back of the text, the distribution of the chi-square, and figure out what your critical value is. And just like you did for chapters 8 and 9, if your chi-square observed is larger than your chi-square critical, you'll reject the null. If it's smaller than your chi-square critical, then you'll fail to reject. And the same logic that you've been doing. And this will be true for analysis of variance and correlation as we go through. The same kind of hypothesis testing, where you've got a null, and you'll notice here on the first couple of pages of chapter 11 are kind of what we just talked about a little while ago. But if you go over to page 262, you'll see the logic of chi-square, and you'll see a bolded word in there called independence. That's really the null hypothesis. If you've got a null hypothesis statement and say, does does the variation in approval for gun control by sex, the null hypothesis would say sex and gun control are independent. It doesn't have anything to do with gender. Your research hypothesis would say that it would. And so the null hypothesis would say that those two variables are independent of one another. So we'll talk a little more about that here in a second. When you get over to page 263, you begin to see how the calculations work. Now, you're not going to have to do this, and it's all going to be happening behind you, or in a sense in the SPSS. But what it does, it takes your observed table from your sample, and always remember, what we do here for chi-squares, crosstabs, correlations, regression, all of this, analysis of variance, are happening at the sample level. These are statistics that you're getting, and anything that you get in your crosstab or any of that, we're saying that if you did representative sample and with a sample size of sufficient, a sample of sufficient size, then you got efficiency, then your cross-tabulated finding is a good estimate of what you would have found had you gone from population to the parameter. We're still in inferential statistics. All right, so here the way they do it is you'll get your observed table, which you'll see in your output here in a minute, and in the background it will have calculated out an expected table. If this were independent, it does a hypothetical thing in the background, much like that hypothetical curve that we saw, something hypothetical to compare against. It does a hypothetical table mathematically derived from your sample that if this were independent relationship, this is what you would expect as an independent relationship. This is what the table would look like if it was independent, these two variables. And then the computer goes back through some algorithms and compares what the observed values in each of your cells against the expected, and goes through some calculations and comes up with a chi-square. And you can see that on page 263, and there's a good illustration of the three tables on page 264, your observed table, your expected table, and then the computation table that shows how the chi-square is derived. This will not be on an exam or anything like that. You're not going to have to do these calculations. You're simply going to interpret them from tables and findings from SPSS that I'm going to give you. Now I'm going to take you on over to page 267. On the left-hand side is one of those, page 266, one of those applications that Healey does so well. If you want to kind of get a summary look at this whole chapter, it's all enclosed in that. So if you want to take a look. I want to draw your attention to Formula 11.3, the degrees of freedom. They're vital. It's a vital formula for what we're going to do here. I'm going to walk you through in a minute. The degrees of freedom are R minus 1 times column minus 1. So if you've got a traditional table, 2 by 2, where you've got 2 rows and 2 columns, then that's 2 minus 1 times 2 minus 1 equals 1. So you'd have 1 degree of freedom. And for example, all these are, if your alpha is 0.05, and they are for all of your demonstrations and homework, if you went over to C, Appendix C, where the degrees of freedom are 1, you went over Appendix C, and you went down the left-hand column, you'd see that very first row is a degree of freedom of 1, and then you follow your finger off to the right until you come to 0.05, and you find that the critical value, chi-square, the critical chi-square is 3.841. And so you would enter that as your critical on a sheet of paper. I'll show you here in a minute. And then when the computer does the calculations, you would hope for a chi-square observed larger than that chi-square critical of 3.841, and then you could reject the null. If it's smaller, you fail to reject. Okay, so now let's take a look. I have no other way to do this than to hold them here like this. So I'm going to take a moment and get a little closer and get off my stool and bring the chair over. Pretty tight operation here, but it seems to work pretty well. Get a little closer to you and get this down a little bit where we can more likely see one another. And what I want to do is take you through these. It's not going to be too easy to do, but I think we can make it work. All right, the first one that I want to show you is, and again, your homework will look just like this. There'll be 4 of these, 2 for ordinal variables and 2 for nominal variables. And you'll see the logic why that's the case here in a minute. And you'll notice already, what is this homework or demonstration? It's got Chapter 14. We haven't even talked about Chapter 14. Well, you're right. Chapter 14 and Chapter 13 have two areas in them that are small. Just look up the 2 or 3 pages that have to do with the lambda in Chapter 13 and the gamma in Chapter 14. Take a look at those. You'll notice that there's a PRE, proportional reduction in error. Now, all that proportional reduction in error means is that when we get this lambda value or the gamma value, we will multiply it times 100, and it will tell us how much of that variation in y is explained by the variation in x. So the proportional reduction in error is, you and I might sit around and surmise and guess why income goes up and down. We might say, well, maybe it's because of the weather, it might be because of anything, and we guess, and by golly, and whatever else. But once we put it in an equation and statistically, mathematically measure it, our error drops. And we have to say it doesn't go away entirely, because remember, we're in a sample. Even though we've got good probability that in our equations, because of our sample size, that we've got something statistically significant, we never really know whether it's absolutely, completely correct. If you recall, what we've talked about all along is statistics is about minimizing the error and not about maximizing the right. If these are things that if we don't actually do the population itself, we never know because we're drawing from a sample. So anyway, keep that in mind. Excuse me. Okay, so here you are. Here's one that is subjective health by subjective class. In other words, these respondents in this survey were asked, how's your health on a scale and what class do you see yourself in? You'll notice that on here, I'm assuming now you've got them in front of you, Homework 8, Crosstab, subjective health by, not Homework 8, but Demonstration 8, subjective health by subjective class. I think I left it as Homework 8, and it's not part of your homework, so it's actually demonstration, so don't get too excited. But anyway, when we look at this, what is the dependent variable? What is the independent variable? In this one, the dependent variable is health. Why does health vary? And the hypothesis, or the independent variable, is subjective class. So we might imagine that as people have higher classes, in other words, as class designations go up, perceptions of health probably go up as well. We might expect a positive relationship here. Your null hypothesis is that these two variables are independent. Neither one nor the other influences the other. The research hypothesis would be that class does, in fact, influence one's perception of health. You see there the alpha of 0.5, as you're holding this in front of you. Degrees of freedom are R1 by C1. So what we have to do here is we go over and look at the table on the next page, and we count up the rows and the columns. We see 4 rows, 1, 2, 3, 4, and we see 4 columns, 1, 2, 3, 4. 4 minus 1 times 4 minus 1 is 3 times 3 equals 9. So that's 9 degrees of freedom. So then we go over to Appendix C, and we go down the left-hand column till we get to 9. Our alpha is 0.5. So we go across the right until we get an alpha 0.05. My finger is pointing to 16.919 as the critical value in this chi-square. So in order to reject the null, we must have an observed chi-square larger than that critical value. So then, while we're on that table, while we're at that table, let's look at the chi-square table, the chi-square test down here at the bottom, and you'll see there, Pearson chi-square. I have a Pearson chi-square of 74. So that 74 is very much larger as an observed chi-square, very much larger than the critical chi-square we just got from the Appendix C. Therefore, when we come back up to this section right here, we would write in our critical chi-square, and then we'd make a decision. We'd say, well, the observed chi-square of whatever it is larger than the critical chi-square. Therefore, we reject the null and class and interpret it and say that class does indeed influence perception of health. And we might say as class goes up, the perception of health goes up. All right. And then you got this value of gamma. And I put the reference here when we're doing this to Chapter 14. The gamma is the proportional reduction of error for ordinal variables. You'll notice that both of these variables are ordinal variables. Poor, fair, good, excellent, lower class, middle class, working class, middle class, upper class, both ordinal. So then we look at the gamma, and the gamma is in the last table of the series of this demonstration. And you'll see right here, it is 0.19. Now, these pre-statistics, proportional reduction in error statistics, multiply times 100 to get percentages. So then we would interpret that about 19% of the variation in class health perception is explained by perception of class. Class explains about 19% of the variation in health, in other words, and that's how that would work. All right, now that's ordinal. Let's take a look at nominal, and the one I sent you is gun control by sex. Here you can see again, it's the same sort of thing. The dependent variable, gun control, by independent variable, sex. The null hypothesis is that they are independent, neither one nor the other explains, sex does not explain gun control. The research hypothesis is that, in fact, is that sex explains it. Again, the alpha, as you see in front of you, is 0.05. Degrees of freedom, we go over and look at the table. This is a classic 2 by 2. We have 2 columns and two rows. So 2 minus 1 times 2 minus 1 is 1 minus 1. 1 times 1 equals 1. So we go over to the Appendix C, and there we find degree of freedom 1, which is the very first row. Go over to alpha 05, and we find 3.841. So now we know if we got a critical of 3.841, we need a critical observed larger in that in order to reject the null. And we come down to the chi-square test table, and we notice that the value there is 56. Very much larger than the critical value of 3.841. So we reject the null, and we can say that that gender does influence gun control ideas. But then we want to continue that. If you look at that, you'll see that for both males and females in that table right here, they both, more than 50% in both groups, favor gun control. But women favor gun control more than do men. So don't just say that sex influences. Describe something of the pattern of relationship that you see when you've got 2 nominal variables. They both approve it, but women more so than men. So give a little extended description there. And then when we come down to the lambda, which is in the next piece, which I don't see on my little sheet of paper here. I'm not sure what it says because I don't have it in front of me. Whatever the lambda says, whatever your lambda says, it's not in my book either. No telling where it is. It's probably still on the printer. Let's not worry about it. Whatever the lambda says, you multiply that times 100. If it's 0.03, then it's 3%. If it's 0.8, then it's 8%. Whatever it is, that is the percentage of the variation in this case, of approval of gun control that is explained by sex. Now sometimes these percentages are going to be very small. Let's not worry about that right now. They would get larger if we're using more variables on the right side of the equation. What we're practicing here is how to do the null, the research hypothesis for these, and the null hypothesis, how to read the tables, and how to do the null in relation to the research, and that sort of thing. So when you get to your gamma for ordinal variables and your lambda for nominal variables, multiply those times 100 and enter that value, in this case what the lambda is, and say if it's 0.036, then about 3.6% of the variation in gun control is explained by sex. And you would explain that. You would make that statement right here. Okay, so that's pretty much Chapter 8. And I'll send you, those of you that are on the online class, I'll send you the 4 homework problems, 2 ordinal problems and 2 nominal problems that you'll work just like we just did. And they'll be due on Tuesday the 19th, which is next Tuesday, a week from today. This is This must be the 12th. So, and then one other thing, on Thursday, this coming Thursday, I'll do a review video for chapters 5 through 9, and I'll have all your homework back by that day. And then I'll post the, for those of you online, I'll post that exam on Blackboard now that I know how to do it. And for those that, well, I'll send this video to the face-to-face class, and you will take that in a 75-minute interval at the assessment center. Okay, so that's chapter 8. Thank you for the good work that you do, and we'll be back in touch at some point.